Good morning. I'm going to show you guys how to do calorimetry calculations so that you can refer back to this before the big test on Friday. Calorimetry's equation is Q for heat equals mass times the specific heat times the final temperature minus the initial temperature. In example 1, let's say that we have a potato chip that we burned, and we burned it underneath 25 milliliters of water. The initial temperature was 23 degrees Celsius, but after we finished burning the potato chip, it rose to 40 degrees Celsius. So we are to calculate the heat energy that was transferred, or the Q. So I'll plug in my values. Remember, 25 milliliters of water, because density is 1, is also 25 grams. That's the mass. The specific heat of water, which will always be given to you, is 4.18. The final temperature, that was 40. And the initial was 23. So what we do is we do the inside first. 40 minus 23. This gives me 17. Now I'm going to multiply it to C and to M. And this gives me a Q value of 1776.5 joules. That's how you solve for Q. Now let's pretend another example where we're actually solving for the mass. Let's say that we have water again, and we know that the water temperature started out at 20 degrees Celsius and rose to 35 degrees Celsius. And we measured the heat energy to be 1700 joules. So let's plug in what we know. Q is 1700. Mass is our variable, it's our X. C is 4.18. The final temperature, 35, minus the initial temperature. Do the parentheses stuff first. I get 15. Take the 15 times the C, 4.18. This gives me, if I recopy all this, 62.7. Now, to solve for M, I'm going to divide both sides by 62.7. These cancel, and I get a mass equal to 27.11. It comes out in grams. If you would like more examples of calorimetry calculations, just let me know. I will do more, but basically you should be focusing on solving for either Q, M, or C. If you're solving for C, you would do the exact same thing as you would do here, except you would have your mass. Okay? Hope this was helpful. Thanks for tuning in.